In this episode, we focus on a reality that surprises many new learners when they first study AI governance. The most dangerous failures are often the ones that feel normal while they are happening. An AI system can produce outputs that look reasonable on the surface, yet still cause harm through unfair decisions, unsafe recommendations, or subtle mistakes that accumulate over time. Supervision is the practice of watching those outputs closely enough that the organization notices problems early, understands their impact, and intervenes before customers, students, patients, or employees are the ones who discover the harm first. For a beginner, it helps to imagine a new employee working a critical role with limited experience, because even if they are talented, you would not leave them unsupervised on day one, and you would expect a manager to review their work until trust is earned. AI output supervision is similar, except the system can make thousands of decisions quickly, which means small errors can become widespread. The goal here is to understand what supervision is, why it matters, how it works at a high level, and what it looks like when it is done well enough to catch harm early without drowning the organization in noise. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Supervision begins with a simple shift in mindset, because many people think the model is the product, while supervisors think the output is the risk. The output is what customers experience, what triggers actions, and what shapes outcomes. So supervision is centered on the question of whether outputs remain acceptable under real conditions. Acceptable includes technical correctness, but it also includes alignment to policy, fairness expectations, safety boundaries, and consistency with the organization's stated intent. A beginner mistake is assuming that if a model was tested before launch, then supervision is mostly optional afterward, but real-world environments change. Users behave unpredictably, and new edge cases appear. Another beginner mistake is assuming supervision means someone watches every output, which sounds impossible, and in many systems it is. Instead, supervision is about designing a set of checks, signals, and review pathways that allow the organization to detect abnormal patterns and high-risk situations early. When a customer discovers harm first, it usually means the organization lacked the right signals, lacked ownership, or lacked urgency to act on what it could see. A supervised system is one where the organization is not surprised by its own outputs, even when the outputs change over time. To supervise outputs effectively, you need a clear definition of harmful output, because supervision without definitions becomes vague observation. Harm can be direct, like recommending something unsafe, approving something that should be blocked, or denying something that should be allowed. Harm can also be indirect, like systematically disadvantaging a group, escalating conflict, increasing customer frustration, or creating confusion that leads to poor decisions downstream. For beginners, it can help to picture harm as an unwanted consequence that would matter if you were the person affected by the decision. In an organization, harm definitions should be tied to the use case, because what counts as harmful depends on context and impact. A model that suggests movies can be annoying when wrong, while a model that influences financial or safety decisions can be harmful when wrong. Supervision, therefore, begins by identifying the categories of harm that the organization wants to prevent, including the most severe harms and the most likely harms. This process also needs humility, because it acknowledges that some harm may be unforeseen, which is why supervision must include mechanisms for learning and expanding what is monitored as new risks appear. Once harm is defined, supervision becomes a question of signals, meaning measurable indicators that harmful outputs may be occurring. Signals can come from the model itself, such as low confidence or unusual input patterns, but they can also come from the surrounding system, such as spikes in customer complaints, increases in manual overrides, or changes in downstream outcomes. The key is that signals must be connected to action, because monitoring without response is just collecting numbers. A beginner-friendly way to see this is as a smoke alarm, because the goal is not to admire the alarm's design, but to get early warning of fire so you can act before the house is damaged. Supervising AI outputs involves choosing signals that are sensitive enough to catch harm early, but not so noisy that people stop paying attention. This balance is critical because if supervisors are flooded with alerts, they will ignore alerts, and then the most dangerous harm will be missed. Strong supervision includes defined thresholds, clear ownership of each signal, and clear expectations about what happens when a signal indicates risk. The organization should be able to show that signals were chosen intentionally based on the harms it seeks to prevent. A major part of supervision is distinguishing between individual harmful outputs and harmful patterns, because both matter and they are detected differently. Some harms are obvious in a single instance, such as a blatantly incorrect denial or a clearly unsafe recommendation. Other harms appear as patterns, such as a consistent bias against a group, a gradual increase in errors for a particular category, or a drift toward overly aggressive decisions. Pattern harms are often the ones customers discover first because they experience repeated friction, while the organization sees only individual cases scattered across time. Effective supervision, therefore, includes aggregate analysis, meaning looking at distributions, trends, and segment behavior over time, not only reviewing isolated outputs. For a beginner, this is like a teacher noticing not just one wrong answer, but a class-wide misunderstanding that shows up across many assignments. Pattern supervision also helps detect subtle failures that might not trigger obvious alarms, such as a model that becomes more confident while becoming less accurate. When organizations fail here, they tend to rely on anecdotal reports, which arrive late and are influenced by who complains most loudly. Supervision makes the organization aware of patterns before reputation and trust are damaged. Human review is often part of supervision, but it must be designed carefully to avoid becoming a bottleneck or a performance. Humans can catch nuance that automated checks miss, yet humans also have limited attention and can become inconsistent under fatigue. A mature supervision design uses human review for high-risk cases, uncertain cases, and cases that trigger policy boundaries, while allowing low-risk cases to proceed with lighter oversight. For beginners, it helps to think of a hospital triage desk, because not every patient needs the same level of attention, but the system must reliably detect who does need urgent review. Human review must also be supported by clear guidance about what reviewers are checking for, because vague instructions like use your judgment create inconsistency and hidden bias. Supervisors need to know what counts as a harmful output, what evidence they should look for, and what escalation pathway exists when harm is suspected. Another important point is reviewer independence, because if reviewers feel pressured to agree with the model or to process quickly, they may become rubber stamps. A supervised system encourages reviewers to challenge outputs when necessary and makes it safe to escalate concerns without penalty. Supervision also depends on understanding where outputs go and how they are used, because harm can be created or amplified by downstream actions. A model output might be a score, a recommendation, a classification, or a prioritization, and each type of output can be misused if people interpret it incorrectly. For example, a risk score might be treated as a final decision rather than a signal, leading to automatic denial when policy requires review. A prioritization output might be treated as a guarantee of severity, causing important cases to be ignored. Supervision should therefore include checks on usage, meaning whether teams are applying outputs according to intended purpose and policy constraints. For beginners, this is like a label on medicine that says take once per day, because the medicine can be useful when used correctly and harmful when used incorrectly. If the organization supervises only the model output but ignores how people use it, it can miss the true source of harm. Good supervision includes training and communication so users understand limitations, and it includes operational feedback loops that reveal when the output is being interpreted in dangerous ways. Detecting harm early requires supervising both the output and the decision environment around it. Another essential element is calibration, which is the relationship between the model's confidence and the reality of correctness. If a system is overconfident, it may present outputs as reliable even when it is frequently wrong in certain conditions, which encourages over-reliance and increases harm. Supervision should therefore include checks that compare confidence to outcomes over time, especially in segments and edge cases, because calibration can drift as the environment changes. For beginners, imagine a student who always sounds confident even when guessing. The danger is not only the wrong answers, but the false trust the confidence creates. In AI systems, confidence can influence whether humans review, whether customers accept results, and how quickly issues are escalated. If confidence is misaligned with reality, the system can hide harm by sounding sure of itself. Supervision counters this by treating confidence as a signal to be tested, not as a truth to be accepted. Organizations that supervise well will notice when the model becomes confident in unfamiliar conditions and will adjust oversight accordingly, often by routing those cases to review or by narrowing the model's scope until performance stabilizes. Supervision must also be designed to catch misuse and adversarial behavior, because not all harmful outputs come from innocent error. People may try to manipulate inputs, exploit known weaknesses, or trick the system into producing unsafe results, especially when the model influences access, money, or attention. A supervised system monitors for unusual patterns that suggest manipulation, such as sudden spikes in specific input forms, repeated attempts that probe system boundaries, or output patterns that look inconsistent with normal operations. For beginners, it helps to think of a store's return policy, because most customers are honest, but a few will try to exploit the rules, and the store needs checks that catch abuse without accusing everyone. The goal is not to turn supervision into suspicion of all users, but to recognize that risk includes intentional manipulation. When organizations fail to supervise for misuse, customers may discover vulnerabilities first and share them publicly, which damages trust and forces emergency response. Strong supervision includes coordination with security and incident response, so suspicious patterns trigger investigation and potential containment. Detecting harmful outputs before customers do often means detecting harmful intent before it succeeds. A common misunderstanding is that supervision is the same as quality assurance, as if it is only about catching mistakes and fixing them. Supervision is broader because it includes governance questions like whether outputs remain within policy boundaries and whether the system remains safe as it evolves. Another misunderstanding is that supervision is only needed for high-impact systems, while low-impact systems can be left alone. In practice, low-impact systems can become high-impact when they are reused, integrated into larger processes, or relied on more heavily than intended. Supervision is also needed because small harms can accumulate, such as repeated poor recommendations that push users away or repeated unfair decisions that create long-term disadvantage. Beginners should also understand that supervision is not a sign of mistrust in AI. It is a sign of responsibility. Just as a responsible organization supervises humans who make decisions, it supervises AI outputs that influence decisions. Without supervision, the organization is essentially delegating decision influence to a system it does not watch, which is incompatible with accountability. Supervision is how the organization stays in control of a system that can operate at scale. To supervise effectively, the organization needs clear escalation and intervention pathways, because detection is only valuable if action follows quickly. Escalation means deciding who is notified when harmful output is suspected, how quickly they must respond, and what authority they have to change behavior, pause automation, or roll back updates. Intervention can take many forms, such as routing cases to human review, tightening decision thresholds, blocking certain outputs, narrowing scope, or disabling the system temporarily. For beginners, escalation is like calling a supervisor when a cashier sees suspected fraud. The cashier should not feel stuck, and the supervisor should have clear authority to act. In AI systems, this must be defined in advance because during a crisis people hesitate, argue, or wait for permission, and harm continues. Effective supervision includes predefined triggers that cause escalation, plus a process for documenting decisions and learning from them. This is also where reproducibility and configuration management become practical, because interventions often involve changing configuration or switching model versions, and those actions must be controlled and traceable. Detecting harmful decisions before customers requires the organization to be able to move from signal to action without confusion. Supervision also requires thoughtful measurement of customer impact, but without making customers the primary detection system. Customer complaints are important signals, yet they are often late, unevenly distributed, and influenced by who has the time and confidence to complain. A supervised organization uses internal signals to catch harm early, and then uses customer feedback to validate and refine supervision, not to replace it. For beginners, it helps to see customer feedback as a confirmatory signal, like noticing smoke smell after an alarm, rather than waiting for someone to call you about a fire. Measuring impact can include operational metrics, fairness indicators, safety outcomes, and quality markers relevant to the use case, but those measures must be interpreted with care. A dip in complaints might mean improvement, or it might mean customers gave up, so supervision must look at multiple indicators rather than a single number. An evaluator will check whether the organization has built a multi-signal view of harm and whether it reviews these signals regularly with accountable owners. The goal is to prevent harm silently spreading while the organization congratulates itself on a flattering metric. A practical example helps tie these ideas together without requiring technical details. Imagine a model that helps prioritize which customer support cases should be escalated, and the business wants faster resolution times. If the model starts deprioritizing certain complex cases, customers might experience repeated delays, and the first obvious sign could be angry messages on social media. Supervision designed well would detect earlier signals, such as rising rates of repeat contacts, increased manual overrides by experienced staff, or growing disagreement between the model's priority and human judgment. It would also examine patterns, such as whether a certain product line or customer segment is being deprioritized more often than before. The organization could then intervene by adjusting routing rules, adding review for certain categories, or narrowing the model's scope while investigating. The key point is that customers should not be the first alarm bell, because by the time customers notice harm, trust has already been damaged. Supervision is the discipline of noticing risk earlier through internal signals and acting with controlled urgency. When you step back, supervising AI outputs is the practice of staying ahead of harm by designing signals, review pathways, and escalation actions that detect unacceptable decisions before customers experience them at scale. It begins with defining what harm means for the use case, then choosing meaningful indicators that reveal individual failures and harmful patterns over time. It includes human oversight where it adds value, but it is not dependent on humans watching everything, because supervision must operate at the speed and scale of the system. It also covers how outputs are used, how confidence and uncertainty are communicated, and how misuse and manipulation are detected. Most importantly, supervision connects detection to action through clear triggers, accountable owners, and controlled interventions. For brand new learners, the central lesson is that AI does not become safe because it is intelligent. It becomes safer because the organization watches its outputs, learns from evidence, and intervenes before harm reaches the customer. When an organization can demonstrate that it detects harmful decisions early and responds effectively, it proves it is supervising AI responsibly, which is exactly what Domain 2D expects you to understand and evaluate.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.